Okay, first thing we have here are 3 points, and we're asked to find both AP, the vector AP, and the vector AB. So AP, we'll take the P and subtract. So the P point is 2, 3, 1, and we'll subtract the A point, which is, no, that's, oh yeah, which is 1, 0, negative 2. Alright, hopefully that's correct. So that gives us a 1, 3, 3. So AP being 1, 3, 3. AB, same thing, I'll take the B point, which is 0, minus 1, 1, and I will subtract the A point, which is 1, 0, minus 2, so that becomes a plus 2 there. So the AP becomes a negative 1, and a 3. Okay, so now we should be able to find the projection of P onto B. So the projection of P, vector P onto B, well, we know that is P dot B, B dot P on B dot B, the one we're projecting onto, times its vector there. So P dot B, so now we've got AP is vector P and AB is vector B. So when we dot product that, we've got 1 times negative 1, just looking at that 1 and that minus 1, so I've got minus 1. I've got 3 times minus 1, which is minus 3, and I've got 3 times 3, which is 9. So I've got that on top. On the bottom, I've got negative 1 times negative 1, negative 1 times negative 1, and 3 times 3. And of course, I'll write it this way, the actual vector B being negative I, negative j, plus 3k. So we should get, so that's a minus 15 on 11, is it? 9, 10, 11, yes. And we've got 3, 4, sorry, minus 5, can't count. So that's a minus 5 on 11, lots of i's, which makes that minus 5 on 11, lots of j's. And then I've got plus times 3, 15 on 11k. So that's my projection. So then when I'm looking at the next part of the question, what I'm really looking at is I've got some line AB, let's go like this, AB, and that's what we've called vector B. That's my vector B across there. And I'm projecting P, which was AP, so let's call that AP. Let's say it's over here, and you're projecting it onto that line. So the projection is actually that line there. That vector there is what we found, the projection. And our AP is here. So if we used this distance formula here, we're finding this distance. We're saying take the projection minus the AP, or the P vector. There's my P vector. That'll give us the D, this as a vector, this line as a vector, and we just want the distance of it. Now, it should be the perpendicular distance. There we go, because it's the projection. So let's do that. So we've got D, where am I going to write it? I'll leave my projection there. That's my projection, so I remember it. Okay, so my distance D being, so I've got the projection. I'll write it in a better way so that I can fit it. It's got minus 1, 3. So that's just this that we've written. Minus my P vector, which was, is, still, always will be, 1, 3, 3. All right. So in that case, I lost that again. So what do I get when I do that? I've got a negative 5 on 11 minus 1, so that'll be negative 16 on 11, because that's negative 5, negative 11 on 11. So I'm just taking the minus 5 on 11 times minus 1 and subtracting the 1, and I'm going to write that as, so I want the distance, so I'm going to have to write that. That's my kind of x value, so I'm going to have to square that. So that's a minus 16 on 11 that I've squared. And then I'm going to take a minus 5 on 11 and a minus 3. 3 11s are 33, so that would be a minus 38 on 11. Of course, you can use your calculator. A 15 on 11 and a minus 33 on 11. So a minus 8. Was one of those a minus? So minus 15 on 11. No, positive 15 on 11 minus 33 on 11. So minus 18. Oops, I've changed colour. On 11. Okay, now I'd reach for my calculator, definitely. So they've all got a common denominator of 11 squared. So square root of 11 squared is 11. On the top, I've got 2024, which does simplify to 4 times 506. So 2 root 506 on 11. And so if I wanted exact, that would be my distance there.